Hello, I'm Jared Harrington, and today I will be discussing Lab 3 magnetic field of a bar magnet. So, to begin, these are a few objectives that can be taken from the lab. So, we will begin by examining the Biot-Savart law in a real life application. We will determine the effects distance obtains on the magnitude of a magnetic field. We'll also be plotting ln bx and ln r to determine the slope and y-intercepts, and we'll compare our experiment with the computational model using GlowScript. So some relevant physics principles slash important equations are magnets, and here on the image aside, we can see that at the south pole of a magnet, the field lines are pointing towards the center, and at the north pole of a magnet, the field lines are pointing away from the center. Then we have the Biot-Savart law, which is this equation right here. We have the magnitude of a magnetic field on the axis, which is this, and the off axis, which is this. And then here are some other equations that are relevant within this lab. So an overview of this experiment was the system was the magnet, the surroundings were everything else on Earth. And then the materials needed were a bar magnet, a ruler slash meter stick, a smartphone, calculator, and tape. Possible errors that I had during this lab were misplacing the magnetic chip location on my smartphone, meaning that it may not have been in the most accurate place that I found. Inaccuracies with measuring distances, meaning that the distance that I found the magnitudes to be at may have been off slightly. And then also, I said other magnets nearby is an error. And I said that because my phone has a MagSafe case. And while this may be negligible, it also could skew the results. So I just wanted to mention that. So here's the procedure for the on axis. I'll just give you a second to look at it. And then here's the procedure for the off axis. And then this is my experiment data. What's important in this equation or in this spreadsheet is the equation of ln bx and ln r. Um, so using the equation from the graph, I found y to be equal to negative 1.4684x minus 12.15. And then using this equation, the n would be the slope. And then to find k, you just take ln k and take it to the power of e. And then from there, you get 5.288 e to the 6. And then you combine the uh, magnitude of the bar, and you set it equal to the magnitude of the dipole. And then from here, this is how I got my answer. And then this was my computational code. And then here is the second half of my code. And then from here, you can see this is the magnitude of B at 45 degrees, which is the off axis. And then this was the value I got in the experiment. And the difference can be summed up to the errors that I mentioned earlier. So for our discussion questions, the first question says, what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnet field? How would your results have changed? So basically, if we didn't account for Earth, Earth's magnetic field would interfere with the bar magnet, and this would cause our results to skew. And then for the second question, what if you were to stick two identical magnets together? If we did that, this would cause the magnitude to double, but the direction would still be the same.